Welcome to grade 11 physical science geometrical optics lesson number 3, the refraction. So today we're going to be focusing on refraction, at which firstly we'll be looking at the speed of the light, and then refraction, refractive index, and optical density. Now, what is a speed of light? So we all know that the speed of light is equal to 3 times 10 to the power of 8 meters per second. Now, we use the symbol which we use symbol, if you look here, we use symbol C to represent the speed of the light. This is in a vacuum and is closely equal to 3 times 10 to the power of meters per second. Now, the speed of the light is a constant in a given media and has a maximum speed of 3 times 10 to the power of 8 meters per second. So in the previous study, we learned more about light reflecting off from various surfaces, and when the light passes through one media into another, we learn more of what happened when a light strikes the surface and then it was then being reflected and then forming an angle of refraction. So the speed of light is like a wave, it's depending on the media through which it is traveling. So when the light moves from one media into another, for example, from air to the glass, the speed of light changes. So you find that it's just like you running, and then when you hit the wall, you changes the speed. That is just like how the light moves. So if a light hits a boundary of a new media, for example, once again, a glass block at any angle which is not perpendicular or parallel, right? Parallel with the boundary. So the light ray which is going to be formed there will change its direction through the next media. So it will appear in a bend way. For example, you are having the light like this, right? So if you strike here, but here we are not having a perpendicular angle. Remember the reflection one, it was based on what is known as perpendicular. That's why we're learning more about light ray and then a normal light and so on. So when the light strike here and it's not perpendicular, it is going to go maybe through and then at a bent way or not, or in a certain way, but obvious it's going to be bent. So we say this is what you call refraction. It is important to know that while the speed of light changes, the frequency of the light remains the same. So it is only the speed which is changing in this case, but we don't have a frequency of a light changing because still we're dealing with the light. So what is a refraction? So refraction occurs at a boundary of two media when light travels from one media into another and its speed changes but its frequency remains the same. So if the light hit the boundary at any angle which is not perpendicular to or parallel to the surface, then it will change the direction and appear to bend. That's the most important things which you need to know so far. So this all which we've been talking about is based on the light, telling us how the light bend. So if the light ray hits a boundary at angle which is not perpendicular. Perpendicular means 90 degree. Parallel, you know what it is by now. So perpendicular means 90 degree and the parallel is to the surface. So then we find that at that case we are going to have the light changing the direction. So, and it will appear in a bent way, like you can see it will appear to change, and it will be bent. Instead of it to work like in a reflection, it will be different. So now imagine a straw. If you take a straw like this one and then you throw it inside there, or you dip it inside the water, right, and you look from above, what is it will happen? So it will be like this, and the straw will be like going down, and then it will be jumping up and down. So it will be changing the direction. So we say that when you look from above at an angle of a straw in a glass of water, the straw appear to bend in the liquid. This is because the light ray leaves the straw, changes the direction when they hit the surface between the liquid and the air. So your eyes trace the light rays light ray backward as a straight line to the point. So most importantly, we are learning on how the light is changing here. So this straw here is showing us the light. This is the incident light. So and then it is going down like this, but it will hit the boundary, but not at a perpendicular or parallel to the surface. Then it will bend, or it will change the direction, the light, and then continue traveling. So that is what this whole statement is talking about. So for it to be reflected, there must be perpendicular. It must the light of incident must be perpendicular to the surface or parallel. So refractive index. So that's what we're going to focus on. It's our third point. So refractive index, what is it exactly? So we say the speed of the light, the speed of light, and therefore the degree of the boundary of the light depend on refractive index. So the degree of bending of the light depend on refractive index, not refractive index. Refractive index. There is an RE. So of a material through which light passes. The refractive index is represented by the symbol, which is an N. So it is the ratio of the speed of light in a vacuum to its speed in the material. So the definition of a refractive index, it says that refractive index of a material is the ratio of the speed of the light in a vacuum to its speed in a material, give the indication of how different it is from light to get through the material. So we have N, which represents, we do have N here. So N represents what is known as refractive index. We say refractive index equals to C divided by V. C is the speed of light, V is the speed of light in a given media. So but this one is the one for the light. So this one, refractive index, and then speed of a media or a material. So from there, let's go to the next one. We can use the definition of a refractive index, which is N equals to C divided by V. We can see the speed of the light changes in direction, in different media, because of the light in a vacuum is constant. So constant means without changing. If a refractive index N increase, the speed of light in a material V must decrease. So the speed of light in a material, if it increase, so it means that if we do have v equals to 10 and then it changes to v, so I mean, like if it increase, then they say that if it increases, therefore n will decrease. So n increase, then v of the material or the speed of the material decreases. Therefore, the light travels slowly through the media of the refractive index. This is when n increases and v decreases. Let's look at the table here. So you go through this table, table 5.1, showing the refractive index for various material. Light travels slowly in any material than it does in a vacuum. So all the values for n are greater than 1. So you can just take a time and then you look through this. So in a vacuum, you find that the first one, in a vacuum, refractive index n is equal to 1. But from there, you realize that for helium, it's 1.000036. In air, this is what we have. In carbon, for carbon dioxide, this is what we have, and so on. But if you look here, if the values for n are greater than 1, so light travels slower in any material, right? So the material, if n is greater than 1, so it means that the light will travel slower than in the vacuum or in an empty space, which means vacuum. So you can go through this once again. Right. Let us look at the problem here. You are given a question here, the worked example. They say calculate the speed of the light through glycerin, which has a refractive index of 1,4729. Right. So you are looking for the speed of light. So what are you going to do? First, a refractive index is given by the letter n, which is equals to c divided by v. So you are looking for v. C is the speed of light, which is equals to 3 times 10 to the power of 8 meters per second. Now, step number 1, determine what is given and what is required. So we are required to find the speed. We use the formula to do the calculation. We say refractive index is given by n equals to c over v. So whereby n is the refractive index, c speed of light, v speed of the material, speed of the light in a given material. So we can really rearrange. We know the value which we are given for the speed of light, which is obvious, 3 times 10 to the power of 8 meters per second. And then we do have refractive index, which was 1.4729. So the only value which were not given was v. That's what we were looking for. Then you substitute, and then if you calculate, you get this answer. You can prove this. Now, activity. This is the activity. Please take a time and then go through it. If you're in my class, you can just submit it to my email or to my WhatsApp or Facebook. And then now let us continue. We do have something called optical density. What is optical density? Optical density measure is a measure of refracting of refracting power of a media. So go through, we learned last time what is a normal. So this is all the work of last time. So normal, we say normal to the surface is the line which is perpendicular to the plane of the surface. Angle of incident is the angle defined between normal to the surface and the incoming or the incident light ray. So now part which you need to cover is angle of refraction. Now refraction, the angle of refraction is the angle defined between normal to the surface and refracted index. So now we'll learn this more when there's a diagram. So now here is the case. So now here you do have what is known as incident ray. This is the light, incoming light. Then here you do have your normal line here. Remember, we are dealing with refraction. So in this case, the light strikes here, not perpendicular or parallel to the surface. That is why it bent like this, and then it's then being refracted. So and then we ended up having refracted ray. And then we do have normal here, which forms 90 degree here. So this is a water and this is air. So in water we say refractive index is 1,3, and then in air is 1.0. Now in this case, if you check it, incident ray, do we have the angle? Let us continue. I was having a challenge of the battery. So the diagram, which is this one, we say we do have a refracted ray. So normal line is here. If you check very well, this is a normal line. So but between normal line here and ray refracted, we do have the angle here. So this is the angle of ray refracted or ray refraction. Then here you have incident ray and normal. So you do have angle here. This is an angle of incident. So angle of incident is between normal and incident ray. Angle of refracted is between normal line here, which is down here, you can see being traced downwards, and the ray refracted ray. So now when a light travels from one media to another, it is refracted. If the angle of incident is not zero, the light will change direction from its original path as it is refracted. Then you do have this still the same. So we say the light is moving from optical dense media to to an optical less dense. So from more dense to less dense. Then the light is moving from less dense to more dense. So let us check here. First here you do have the diagram here. So if you check it, it's moving from optically dense media to less dense. So it comes here straight, and then when it strike here, it was supposed to go maybe straight, but it then bent like this. right? Because it is more dense. When it's more dense to less dense, then you find that the angle is gonna be greater than the angle of incident. Then from there, if you check here, it is more dense. So it's moving from less dense to more dense, right? To or an optical denser media. So if you look here, this angle is more than it's less. Here is another activity, which is the last activity. Please attempt it and do submit. I'll appreciate to say how you understand it through this. Thank you for watching.